This is Chapter 1, Section 3. So we're going to look at some of the elements in the periodic table, the basic breakout of the periodic table. Please have your periodic table handy to look at as we go through this particular section. So starting off with our introduction to the periodic table, when we look, let me back up here. When we look, first thing I hope you noticed when I gave you those 60 or 70 to look at, some of the element symbols did not match up with the name that was given. It is very, very common. For instance, hydrogen, the first letter is H, so that's its symbol. Or helium, since H was already taken, the first two letters are used, H and E. First letter is always capital. The second letter is always lowercase, so that's the general way in which the names and symbols are going to match up. But we've got some where the symbols and names don't match up, and it's because you have several. Their original root was German or Latin, some other foreign language, and even though the name was changed with our international system, they kept the symbol of the original or older name. Please look through this list. Make sure you know a couple of them. That way you are familiar with it. Some of the more common ones there at the bottom, tungsten is a W, and its older name was wolfram. And I've also got gold, AU, and its original Latin name was aurum. So again, look at these, write down at least a couple of them so you're familiar with why some of the names and symbols do not match up. Going back over to the periodic table, we're going to look at the different regions in this section. So all of these that are in the red color are considered metals, and you can see that metals make up the majority of the periodic table, and we'll break down some general characteristics of those. Metalloids are right along this stair-step line. We talk about a stair-step line here. And we're going to concentrate on the 6 in orange that are listed there: boron, silicon, germanium, arsenic, antimony, and tellurium. You'll have a chance to write those down. And then the other part of the periodic table, everything in green, purple, and white are going to be considered our non-metals. Green, purple, and white are our non-metals, but we are going to break those down. We've got our non-metals in green, our special category, which is that last group 18 in purple, and then hydrogen kind of off by itself. It is there above the first group, but it is definitely not a metal, and we'll get into some specifics there. So make sure you know the overall layout of your periodic table. The color coding is important. I suggest that you have a makeshift drawing of the periodic table, give it a little bit of color, and look at these 4 classifications that we're looking at here. So starting off, all of those vertical columns, they are called groups or families. Make sure you write down definitions for these. And we have 18 groups in our current periodic table. So groups 1 through 18, they are vertical, meaning up and down. And if elements are in the same group, typically they will have similar chemical properties. The rows that's left to right, those are called periods, and we have 7 periods on the current periodic table, and you will find a wide range of properties from left to right when you go across the periodic table. And again, you should be able to see that if you go back and look going from left to right within the periodic table. You've got metals on the left, then as you move right, you're going to have metalloids, non-metals, so the properties are changing. Now, looking at our metals, making sure we get down some of the properties of metals, write down its definition. It is a good electrical conductor and a good heat conductor. Most of our metals are solids at room temperature. The one exception to that we will look at right now is, hopefully you have found it, it is mercury, and you are probably already aware of that. So mercury is one of those that is a liquid at room temperature, even though it's a metal. Metals typically are going to be malleable, ductile, and are good conductors of heat and electricity. We covered malleability and ductility just briefly in the previous section, make sure you have down those definitions. So those are our metals. There's 3 examples of metals. There on the left, you've got a chunk of gold. In the middle, you have copper. It's showing its ductile properties. It can be drawn into a fine wire. And then on the right, we've got our aluminum, where they have made aluminum foil. So that shows the malleable properties of it being hammered or rolled into thin sheets. Moving on to our nonmetals. Nonmetals are going to be poor conductors of heat and electricity. And with our nonmetals, we have solids, liquids, and gases going on within the nonmetals. Many of them are gases, but we do have some solids, and if they are in the solid state, they are going to be brittle, which means they break easily, and these are poor conductors of heat and electricity. Let's go take a quick look at some of our solid nonmetals. We've got 4 of them. And here they are. Carbon on the left, the yellow is sulfur, the red is phosphorus, and the right is iodine. I used to work at Goodyear Tire and Rubber. We made tires, and 2 of these elements went into every single tire we made. I'm hoping you can guess one of them. Yep, it's the carbon. That would be the reason why the tires are black. But sulfur is also used in tire making business because of its vulcanization properties that it has. And then moving on, our metalloids. Metalloids are right there in that stair step between our metals and our nonmetals, so they're going to have characteristics of both. And these are all solids at room temperature. We call these semiconductors. So they do conduct electricity, not as good as metals, but definitely better than nonmetals. Make sure you know those along the stair step line. Again, these are boron, silicon, germanium, arsenic, antimony, and tellurium. Some references you might look at will add polonium into that, but we're going to go with those 6. And again, these are semiconductors. They're all solids. And if I also look at these, one of these is used often within the tech industry, and that is your silicone. Now, even though noble gases, we're breaking that out into a 4th classification, our noble gases are really nonmetals. And this is all of group 18, so that far right group in the periodic table. Nonmetals or noble gases are typically unreactive. They used to be called the inert gases, inert basically meaning unreactive, because they thought at one time all of the noble gases were unreactive. But the first 3, helium, neon, and argon, are still considered to be unreactive, but the rest of them, they have found a couple other elements in general that they will react with, your krypton, xenon, and radon. And if you have element 118, I'm sure it does too. That is it for section 3.